Hello everyone, Anshul and I are here to tell you a little about cryptography and in detail about XOR encryption and decryption. To start with the origin of cryptography, humans from ages had inherent needs to communicate and share information and to communicate selectively. These two needs gave rise to the art of coding the messages in such a way that only the intended people could have access to the information. Unauthorized people could not extract any information even if they had the scrambled messages in their hand. The art and science of concealing the messages to introduce secrecy in the information security is recognized as cryptography. The word cryptography was coined by combining two Greek words, crypto meaning hidden and graphene meaning writing. Modern cryptography deals with operating bit binary sequences. It relies on publicly known mathematical algorithms for coding the information. Secrecy is obtained through a secret key which is used as a seed for the algorithms, the computational difficulty of algorithms, absence of secret key, etc., which makes it impossible for an attacker to obtain the original information even if he knows the algorithm which is used for coding. Modern cryptography requires parties interested in secure communication to possess the secret key only. Okay, what is cryptography? Cryptography is the art and science of making a crypto system that is capable of providing information security. Cryptography deals with the actual securing of digital data. It refers to the design of mechanisms based on mathematical algorithms that provide fundamental information security services. You can think of cryptography as the establishment of a large toolkit containing different techniques in security applications. The various components of a crypto system are as following. The plain text. It is the data to be protected during transmission. And next comes the encryption algorithm, which is the mathematical process that produces a ciphertext for any given plain text and encryption key. It is the cryptographic algorithm that takes the plain text and an encryption key as input and provides ciphertext. Ciphertext is a scrambled version of plain text produced by the encryption algorithm using a specific encryption key. The ciphertext is not guarded. It flows on public channel. It can be intercepted or compromised by anyone who has access to the communication channel. The decryption algorithm is also a mathematical process that produces a unique plain text for any given ciphertext and decryption key. It is a cryptographic algorithm that takes a ciphertext and a decryption key as input and outputs a plain text, which was the original input that we wanted to send. The decryption algorithm essentially reverses the encryption algorithm and is thus closely related to it. Next comes the encryption key. It is the value that is known to the sender. The sender inputs the encryption key into the encryption algorithm along with the plain text in order to compute the ciphertext. The decryption key is the value that is known to the receiver. The decryption key is related to the encryption key, which is obvious, but it is not always identical to it. The receiver inputs the decryption key into the decryption algorithm along with the ciphertext in order to compute the plain text. XOR. XOR encryption is a common method of encrypting text into the format that cannot be trivially cracked by an average person. The encryption by XOR is a simple symmetric cipher that is used in many applications where security is not a defined requirement. The XOR operator returns 0 when both the inputs are same and returns a 1 if either of them is different from the other. Now, let us see the sample code that is given in NETSIM for XOR encryption and decryption. For the sake of simplicity, let us take the plain text to be A and the key text to be S and run, which gives the ASCII value as 18 and gives us a ciphertext. Now going to decryption, it already has the ciphertext and the key text. We just need to run the code, which again gives back the A, that is the input that we initially gave. Now, Anshul will continue with the user part of the program.
So, now we will go towards the user code. First, I'm going to run the user code.
and then I'll explain the code. So clicking on the user icon, it will ask us to add our own code, and we'll ask the encode one first. After adding the own code, we'll just write over here. Let's take the same alphabets which we are used. So let's take A and let's take S. A as the plain text and S as the key text. Now if we run the code, showing plain text, key text, ASCII binary value of the plain text, ASCII binary value of the key text. Then it does the XOR operation between these two, gives the output and converts it to the ASCII equivalent, and you get the ciphertext. Now let us go towards the decryption part. In decryption, it automatically takes the ciphertext and it takes the key text. Now what we have to do is we have to add the user code for decryption. That we can do by adding the decode part. We add this, okay, and now we run it. So as we can see, it took the ciphertext, it took the key text, it took this binary hexadecimal value of the ciphertext, took the binary value of key text, and then it XORed both of them and gave us the XOR output and the ASCII equivalent of that output, and we got the plain text back, which was A as we gave in the starting. So this is the user code and it's working same as the sample code. Now let us go towards the code. So this is the encode part. In this, we first include all the libraries and header files that we need. Now coming down, these and all are already included in the source file that we get from the NETSIM. Interface source file already has all the included header files and all the required variables and everything defined. Let's understand these variables. Over here we have 4 variables which are path. These paths will tell where the input that we are writing in the program goes. Like the input path puts it into a text file named input.txt, and the output path specifies the path to the output file output.txt. Finally, whatever output we have to give should be written in the output.txt file. Now coming to these variables. These variables, each of them are used in the function for encryption. Like these 2 variables, which is text string and key string, are used for XOR operation. This variable is used to store the final result. These 2 variables are used to get the character from the input txt file. And these are the loop variables, and this is the variable to get the length of the loop. Now coming towards the functions, there is already a predefined function decimal to binary in the interface code given. This function takes into an integer and gives us out the hexadecimal value of that integer. This hexadecimal value is finally used for XORing 2 numbers. The next function is read XOR input. What this function does is it reads all the input that it put into the box of key text and plain text and put it one by one into the file named input.txt. How it is done, let's look over here. First we open the file, and in this file we go line by line. If we find a character which is \n, then that means that there is no more entry in the file, and we break the loop and we come out of the input.txt file. But if there is character, we keep on adding it to the sz_text.xor variable, and this variable will go into the XOR loop operation. So we are adding one by one each character to this variable. This is done for the plain text. Similarly, the same method is done for the key text. In the key text, what we do is just the same as what we did for the plain text. First we check if the file exists. If it doesn't exist, we break the loop at that point only. If it exists and the only character present in it is \n, that means that there is no value present in the key text, and we again break the loop. If we have any junk value, then again we break the loop. Otherwise, if we have values which are other than junk values or the end character, we map it one by one to the variable key XOR encode, which will again be used in the XOR function. After mapping one by one to this, we close the function, input function. We go to the encryption code that we have written. This is the user code that we had to write in the interface code for it to work. Now let's begin one by one. In the starting, what we did was we initialized all the loop variables given to us to 0. In this way we can use it normally in our loops. Next, what we did is we got the length of the XOR string. What this length will do is will give us the limit of the for loop. This length is nothing but the length of how long the text string we have given. Suppose we have given just a character A, then the length is just 1. Now what we are doing is we are allocating a particular part of the memory for the output. So we have allocated a size of 200 characters to the output path, and this output path is copied from this temporary path, and we are putting the file name as output.txt and we are opening it in the form of writing. What we will do is one by one we will write each and every output with an output path and output.txt file. So now coming towards the loop. In this loop what we do is we start it and we take for less than the length of the input text string and we increase it one by one. We are first getting the ASCII value. This function basically helps us get the ASCII value. What we are doing is we are getting the particular character at that position. This is basically a character and we are subtracting a ASCII value of null. So this will return an ASCII value of this character. And this character is now passed towards the decimal. This decimal is getting the input as an integer and now it will give an output of a hexadecimal binary value. So this binary value is passed to the exact text string which will be used for XORing two strings. Now we are passing this value into the output file as well so that it can be shown in the output. Next is done the same way for the key text. Again the key text is taken, we get the ASCII values and we convert it to binary, put it in the variable sz key string XOR encode and then we write it to the output variable. Now what we are doing is, this is the final output variable that we have and we are initializing it with the null string so that there is no garbage value presented. This is the part where we actually do the XOR encryption. In this what we do is, we write a loop to go through each and every character of the variable sz key string XOR and the variable sz text string XOR. So if both the characters are same, like if the key string and the text string have the same value, like both have 1 at that position, then the XOR result will give us 0. If both has different value, like one is 0 and the other is 1, it will give us 1. This is done by this if and else statement. We are comparing the location of both, same location of the variables, and if it is equal then we put that value as 0, otherwise we put the value as 1. Finally we are putting \0 at the end of the whole looping process to map it to the 0 part. And we are putting this final XOR output into the writing file. After writing this to the file, this output will be shown in the output of the interface. And now we close the function. Next comes the main function. In the main function, what we are doing is we are calling these functions one by one. First we call the read XOR input function, which will read the input from the user and write it in the input text file. And then we call the encryption function that we have wrote to take the input from the input file, do the XOR encryption on it, and finally store it in the output. And finally it returns 0. This is the encoding code. So now let's go towards the decode code. It remains the same, almost same, except the decode part. So let's just directly skip towards the decode part in it. So in the decode part, what we are doing is this. First again we are initializing all the variables to 0 and then we are getting the length of the bit that is there at the ciphertext box. This is coming from the read input for decryption file. Now we are allocating a particular memory size for the output.txt, and we go ahead and we are writing each of them in the output.txt file. Now for the loop, what we are doing is we are dividing it for 8. Like if there are 16 bits in the ciphertext, we have 2 characters. So what we are doing is we are taking the length of the bits that we have and we are dividing it by 8 to get 2 ciphertexts. And now we are copying that string, that substring, into the variable text string XOR decode, which will be used for XOR operation for decoding, and we are passing it to the output file as well. Next, what we will be doing is we will take the same thing for the key variable. Now the key variable is in form of character only, so what we have to do is we have to convert it to the ASCII value, which is done in the same way as it was done in the encode. Now we copy it to the decimal to binary function to get the hexadecimal output from it, which is stored in the SZ keystring XOR decode variable, which will be used for the XOR operations. Now we also copy this variable into the output file so that this can be shown in the output interface. Next, we make the final string an empty string so that there is no garbage value present, and this loop is the same XOR loop which we use for encoding. We compare the current location of the text string as well as the key string. If both the binary values are 1, then the output is 0, and if both the values are different, then the output is 1. After doing this, we put an end string, null string at the end, which means that there is no garbage value present and the operation ends over there, and we close the file. Again, in the main part, we call each functions one by one. First, the reading input XOR input function is called, which reads the XOR input for decryption, and the function XOR for decryption is called, which does the decryption. So, this was the video on how to perform encryption and decryption in the XOR method using the sample code present, and also how to write the user code to do the same. Thank you for watching.